The kinetic theory of matter explains that all substances are made of tiny particles, atoms or molecules that are always in motion. The amount of movement depends on how much energy the particles have, and this motion determines the three states of matter. In solids, the particles are packed closely together and can only vibrate in fixed positions, which is why solids have a definite shape and volume. In liquids, the particles have more energy, can move past each other, and this gives liquids a definite volume but no fixed shape. In gases, particles have the most energy, move very fast, and spread far apart, so gases have neither fixed shape nor volume. The random movement of tiny particles can be observed in Brownian motion, where small dust or pollen particles appear to dance under a microscope because invisible molecules are constantly colliding with them. In gases, these fast-moving particles repeatedly hit the walls of a container, and the force of these collisions creates gas pressure. The faster the movement or the more particles present, the higher the pressure. All this motion is closely related to heat and temperature. Temperature measures the average kinetic energy of particles, how fast they are moving. Heat, on the other hand, is the total amount of thermal energy a body has and depends on both temperature and the number of particles. Heat can move from a hotter region to a cooler one through three methods: conduction, convection, and radiation. In conduction, heat travels through direct particle-to-particle contact, which is why metals heat up quickly. Convection occurs in liquids and gases, where warmer, lighter regions rise and cooler, denser regions sink, creating a current. Radiation does not need any medium. Heat travels as infrared waves, such as the warmth felt from the sun or a fire. When heat is supplied to a substance, it can either raise its temperature or change its state. The amount of heat required to raise the temperature of 1 kilogram of a substance by 1 degree Celsius is its specific heat capacity. Different materials require different amounts of energy. For example, water has a high specific heat capacity, meaning it needs a lot of heat to warm up. Sometimes adding heat does not increase temperature. Instead, the energy is used to overcome the forces holding particles together, causing a change of state. This energy is called latent heat. The latent heat of fusion is the heat needed to change a solid into a liquid at its melting point without changing temperature, while the latent heat of vaporization is the heat needed to change a liquid into gas at its boiling point. This is why heating and cooling curves have flat sections where the temperature remains constant during melting or boiling, even though heat is still being absorbed or released. As substances gain heat, their particles move faster and tend to push farther apart, causing thermal expansion. Solids expand the least because their particles are tightly packed and strongly bonded. Liquids expand more, and gases expand the most because their particles move freely and have weak intermolecular forces. Thermal expansion explains real-life phenomena such as gaps in railway tracks, the bulging of hot water pipes, and the rising of hot air in the atmosphere. Altogether, these concepts, particle motion, energy, heat transfer, change of state, and expansion, form the foundation of the kinetic theory and help us understand how matter behaves in everyday life. Like, share, and subscribe for more science concepts explainers.